Okay, trigonometry fans, let's take a look at section 4.4, trigonometric functions of any angle, an awful lot like 4.3, except now we're going to be moving through all quadrants. As you note here, we have an angle theta that's entered the second quadrant, where in the last section we're pretty much exclusively just dealing with first quadrant angles. As we do that, we're going to be discussing reference angles. Prior to that, though, let's just take a look. There's nothing new here. These are our trigonometric ratios of side lengths that I refer to as our 2 a.m. wake-up calls. So we need to know sine is in terms of not just opposite and hypotenuse, but y over r, cosine x over r, tangent y over x, etc. If you remember those three and you know the reciprocal properties of trigonometric functions, if you know cosine x over r, you should know that secant is r over x, etc. Okay, so a reference angle is an acute angle. I'm going to use an angle similar to this. Let's say we have an angle theta that's entered the second quadrant here. The reference angle for that often would be called theta prime, and it's always with the x-axis and the terminal side of the angle that we're talking about. So it would be this angle. It's never to the y-axis. It's always acute x. So lots of times what we'll be doing is just dropping a triangle to the x-axis, but we create angle theta here, x-axis, terminal, it's always acute. Okay, let's go ahead and take a look at these. This section is going to have a lot of problems that are very, very similar to one another. They're just going to change the directions on you a little bit. But the section I joke should probably be called let's build a triangle in a quadrant, do some Pythagorean, get some side lengths, and find the trig functions. So in this case, if I drop my triangle here, this length would be 3, this length would be 1, the height is 1, and therefore, because I have y and x, had them here, I've got enough information to know tangent. Tangent is y on x, or 1 on 3. Cotangent is the reciprocal of. But we need r to know the rest of these, so we need some Pythagorean help. So Pythagorean, 3 squared 9 plus 1 squared 1, 9 plus 1, 10. This side is square root of 10, which makes sine the opposite 1 on the hypotenuse, or better yet, y on r, 1 on square root of 10. I'm going to put it over here. Rationalize that square root of 10 on 10. Cosecant the reciprocal of sine, plain old square root of 10. Cosine, likewise, x on r, 3 on square root of 10, or rationalize 3 square root of 10 on 10. Secant, reciprocal, square root of 10 on 3. And that's pretty much the theme of this whole section. Okay, B. Same problem, different quadrant. The distance across here for the x value is square root of 5. The y value is down 2. We have enough once again for tangent. Tangent, opposite adjacent. Again, better yet, y on x, negative 2 on square root of 5. Rationalize, negative 2 square root of 5 on 5. Cotangent reciprocal, the opposite of square root of 5 on 2. And now we need some Pythagorean work. But square root of 5 squared 5, negative 2 squared 4, 5 plus 4, 9, square root of 9, the hypotenuse or the radius, r, equals 3. Sine, y on r, negative 2 on 3, cosecant reciprocal. Cosine, x on r, square root of 5 on 3. Secant, the reciprocal, I'm going to jot it down here, 3 on square root of 5, but rationalized, 3 square root of 5 on square root of 5 times square root of 5, 5. And that's it. And now you're going to see, they're going to try to disguise this as a different problem, but it's the same problem. The point is on the terminal side of an angle in standard position. So we have, this is third quadrant, we have an angle that rotated around until it went through. I'm not even going to try to draw it to scale. It went through the point -3, negative square root of 7. So I build my reference triangle. Here's the reference angle. This distance is 3 to the left, down square root of 7, tangent y on x, the negatives cancel, square root of 7 on 3, cotangent wants to be 3 on square root of 7, but we clean it up, 3 times square root of 7 on 7 by rationalizing, as you can see. Cosine, sine, cosecant, secant, we need r. Well, square it, the negatives get canceled. I get plain old 7 plus 9. 7 plus 9, 16, square root of 16. This side's plain old 4. And the radius is always considered to be positive. Hypotenuse, always positive. So sine y on r, -7, negative square root of 7, on 4. That reciprocal, I'm going to write it down here, would be -4 on square root of 7, or as we can see, -4 times square root of 7 on 7 when we rationalize. Cosine x on r, -3/4, so secant's a breeze, -4/3. And that's it. Okay, now cosecant 4's function value, they get a constraint says cotangent's less than 0. What's that all about? Well, if cosecant is 4, cosecant is sine's reciprocal, sine is y on r, this is r on y. R is always positive, y must be positive. So what quadrant should I build this in? Should I have a triangle in the first quadrant or a triangle in the second? Those are the only two quadrants, or those are the places where cosecant is positive. But they say cotangent is negative, and all students take calculus. Tangent's positive here, so cotangent's positive here and here. Where is cotangent less than 0? Here and here. Therefore, we're going to build this triangle in quadrant 2. Relatively small y value, sorted to scale, but not really entirely. Y value of 1, r value of 4. We've got cosecant already, was 4, so sine is 1/4. And now, a little Pythagorean work, 16 minus 1/15. This is the square root of 15, but careful, it is to the left. Always, when we're building triangles, checking our positives, negatives. Very easy to forget that. So cosine is x on r, negative square root of 15 on 4. Tangent is y on x, wants to be 1 on negative square root of 15. That, of course, is negative square root of 15 on 15. Cotangent is the reciprocal of this, or this, but this one's easier to work with, negative square root of 15. And secant wants to be the reciprocal of cosine. I'll jot it down over here. -4 on square root of 15. Rationalize, square root of 15, square root of 15. And we get -4 square root of 15 all on 15. Okay, tangent is undefined. Well, tangent of theta, tangent of an angle, is y on x. If it's undefined, it means x is 0. When is x 0? Either when I've rotated around to here or when I've rotated around to there. But then they tell us our constraint, we're somewhere between pi and 2 pi, so here's where we end up, right here. And we can, for convenience sake, we can call that 0, -1. And you would get the same answers if we reduced, if we called that 0, -10. In this case, r is 1. If this is -1, r is a length of 1 that we're spinning around on. So that's clearly our most convenient values. Sine is y, -1 on r, 1, -1. Cosecant reciprocal, -1. Cosine is the x value, 0 on r, 1, 0 on 1, 0. Reciprocal of 0 on 1, 1 on 0. Undefined. Tangent we knew was undefined. Cotangent is x on y, 0 on -1, 0. Okay, more of the same. They're going to keep trying to fool us with things, but here they tell us the terminal side lies on the line in the specified quadrant. Quadrant 4, we're going to build this. This is the line. I'm going to solve this for y. 3y is -4x. Y is -4/3 x. So this has a slope, a y-intercept here, which it would have to have, and a slope of down 4 over 3. So once again, same problem as the very first couple problems we looked at. I know what this y value is when I build my reference triangle. Here's my reference angle. I know y is 4, but it's negative. X is 3. And Pythagorean work, this is an easy triple. R is +5. So we got everything we need. Sine y on r, -4/5. Cosine x on r, 3/5. Tangent y on x, -4/3, and reciprocals. Okay, so a really easy one. It was nice that it was such a friendly little Pythagorean triple there. All right, 39 through 46. Evaluate the trig function of the quadrant angle. I'll refer to those as quadrantal angles. So pi on 2 just takes us halfway to pi. So it's right here. For convenience sake, we'll label this 0, 1. And that truthfully is all I need, but the radius would be 1 as well that we're spinning on if this is 0, 1. But for tangent is just y on x, and we've got y on x. Y on x is 1 on 0, or undefined. Secant of 0 puts us right here at the point that we would label for convenience 1, 0. And again, in this case, the radius we're spinning on is 1. Well, secant, reciprocal of cosine, cosine x on r, secant r on x. R on x, 1 on 1, or I guess I'll just do this, secant of 0 equals 1 on 1, 1. Find the reference angle theta prime for the specified angle. Sketch theta in standard position and label theta prime. So -330 degrees spins us around a whole way backwards, would be -360. So we're 30 degrees short. Looks something like this. Here is theta. Here is theta prime. It's just this little angle. 56, 7/6 pi. 6 tick marks to go half a circle. 1, 2, 3, 4, 5, 6, and a 7th one right here. So our angle terminates there. Here's how we got there. Spun around this way. There's theta. But right in here is little sneaky theta prime. That angle to the x-axis. -165. That is 15 degrees short of -180. Something like this. Here would be theta. In here is theta prime. Now, throw us off track here a little bit, careful. This is radians here. This is radians. So negative 3.14 would spin me around to here. Negative 6.28 would spin me around to here. This is 1.57 from here to here, but I only need a little bit more, so we're somewhere right around in this range. So how did we get there? We spun backwards around to here, and then actually all the way to there, but theta prime is right in here. Okay, not too bad. In 67 through 78, evaluate mercifully just sine, cosine, and tangent of the angle without using calculator. So without using calculator, let's figure out where we're at. We went negative 360 to here. That leaves me with, if I subtract 360, that leaves me with 135. That's 90 of it. 45 more, we actually spin around to there. But this is our reference angle. So reference triangle, it's a 45. So we could do this a couple ways. We could put this on a unit circle, or we could go ahead and use values that maybe we're comfortable with for the triangle. So we could either be calling this point right here, it would be middle, for those of you who are in my class, know what I'm talking about there. This would be negative square root of 2 on 2 and down, negative square root of 2, 2 on 2 down. Or we could go ahead and label this with convenient values, 1, 1, and square root of 2, but left and down. Either way, this has its advantages because this tells me the sine is negative square root of 2 on 2, and the cosine is negative square root of 2 on 2. This would quickly tell me that the tangent is negative 1 on negative 1, although this divided by this gives me that. Had I gotten sine from these values, I would have negative 1 on square root of 2, which we see quickly leads us to there when we rationalize. Okay, 10/3 pi. I think the theme here is we're going more than a revolution, because 6/3 pi would get me around to here. I need 4 more thirds pi. 1, 2, 3, 4. Getting me to this 60-degree pi on 3 reference angle right here. There's our theta prime. So here, once again, we could say, well, that's a 60, so this is short, long. We could say this is the point negative 1/2 short, long, negative root 3 on 2 down. Or we could use values that we're convenient with that aren't on the unit circle, in which case this would be negative 1, 2, and negative square root of 3. But sine works really well from here, negative square root of 3 on 2, cosine, negative 1/2, and tangent is either this on this, this on this, and take a look at this. The 2's cancel, the negatives cancel, I just get square root of 3, or it's y on x from here, negative square root of 3 on negative 1, square root of 3. So both have advantages. I don't think I'd typically do it both ways as I've done on these two problems, but if I tell you what, if they were just asking me for sine and cosine, no doubt I'm going with unit circle if I know those values. Okay, let's continue. Find the indicated trigonometric value in the specified quadrant. So we're in quadrant 2. We have a cotangent ratio of negative 3, so I'm going to make it negative 3 on 1. Cotangent 2 a.m. wake-up call is x to y, so it looks something like this, where this is negative 3 and this is 1. Mistake people make is they just think every angle, because of the last sections we've been going through, is either a 30 or a 45 or a 60. This is most definitely not in a ratio of a 30, 60, 90. I haven't really quite drawn it to scale. It would be much shorter than that. But Pythagorean would probably need it. If they asked for tangent, I wouldn't need it at all. Of course, I wouldn't even need a diagram. Pythagorean sine, we need r. Sine 2 a.m. wake up is y on r. 9 and 1, 10. This is square root of 10. So sine of theta, right here, here's theta prime. Sine of theta is equal to sine of theta prime, provided we include the negatives. It's y on r, 1 on square root of 10, or square root of 10 on 10. Cosine ratio is 5/8 in quadrant 1. Cosine ratio is 5/8 in quadrant 1. 2 a.m. wake-up call, x on r. So not trying to draw to scale. Might be close. This is 5. This is 8, x to r. Pythagorean, 64 minus 25 is 39. This side is square root of 39, and that's positive. Secant ratio is r on x, so r 8 on x 5. Oh, how about that? We could have gotten there in one step immediately without drawing our triangle at all. We went from cosine to secant. The lesson there is, let's not necessarily just be robotic about things. Let's think about things, evaluate a little bit. Okay, more of what we did a little bit earlier. Use the given value, trig value to find the remaining trig value. So we have secant is negative. So secant is negative when cosine is negative. So forget about cotangent right now. Cosine is negative, x on r, when x is negative. X is negative here and here, or all students take calculus. All are positive, students take cosine's positive here. Cosine can be negative there, secant's negative there. So I'm going to build that triangle. This is our r on x ratio, negative 4 to 3. This must be 4, and the x must be negative 3. Careful, this is most definitely not 5. Oh, am I in the right triangle, though? Wait a minute. This says cotangent is positive, so I could have been here as well. See where we're still in the right ratio, but this says cotangent is positive. And cotangent is positive. All students take tangent's positive here. This is the one we want. Does that matter? It most definitely does, because the y values would be different. This one would be positive, this would be negative. Pythagorean, 16 minus 9, 7, square root of 7, but negative. So that constraint's really important for us. Sine y on r, negative square root of 7 on 4, cosecant, 4 on, or negative 4 on square root of 7, negative 4 square root of 7 on 7, cosine x on r, negative 3/4, secant reciprocal, negative 4/3, tangent y on x, negative square root of 7 on negative 3, so positive square root of 7 on 3. Cotangent wants to be 3 on square root of 7, or 3 square root of 7 on 7 when we rationalize that. So just more of the same. Where are we going to build the triangle? Use a calculator to evaluate. Well, that's merciful. Round your answer to 4 places. So on, let's go to mode. Our mode needs to be in degrees, as you see, for 94. We're in degrees. So I'm just going to go cosecant. Well, cosecant is 1 divided by sine of 320 degrees. So 1 divided by sine 320 degrees. And we get approximately negative 1.5. How many? Round to 4 decimals. 5.557. Cotangent is 1 divided by tangent of, in this case, negative 15 pi divided by 14. Not a good triangle for us. So I need to go to radian measure here. We're most definitely in radians, no degree symbol. The pi's kind of a giveaway, but no degree symbol is what it's about. So I'm going to go mode, radian, quit. And now I'm going to go 1 divided by tangent of negative 15 times pi divided by 14, and rounded we get approximately negative 4.3813. Okay, wrapping up here. Find two solutions of each. Give your solutions in both degrees and radians, and we're going to go one positive revolution in degrees and one positive revolution in radians. And cotangent is negative square root of 3 or negative square root of 3 on 1, and that is the x to y ratio. So where can cotangent be negative? Here and here. All students take cotangent is positive here and here, negative here and here. The ratio, I'm going to try to draw this one to scale. X is longer than y. So here's our negative square root of 3. Here's positive 1. That looks like a familiar triangle. And likewise over here, x is longer. So here's a square root of 3 to negative 1. And sure enough, that is a 30, and that is a 30. So in degrees, theta is 30 short of 180, 150, and 30 short of 360, 330 degrees. In radians, those are tick marks of 1, 2, 3, 4, 5 sixths pi, 6, 7, 8, 9, 10, 11 sixths pi, or 1 short of 12 sixths pi. Cosecant is 2 or 2 on 1. You may want to take this and go, well, when sine of theta is 1 on 2. You can do that. We could have changed the last one to tangent. I'll just work with cosecant. Sine is y on r. This is a r on y. So I'll act like I didn't even think about that. And now this is when we're in the what quadrant? When is cosecant positive? All students, here's where sine's positive, second. So we are positive in the first and second quadrant. That's a relatively long r compared to y. Here we're 1. Whoops. I'm sorry, compared to y. That was terrible. Try that again. Relatively long. I'm going to squeeze that one. Sorry about that. I'm just going to redo that one. That's my height. That was not good. Relatively short y compared to r. This could be a 1, a 2, a 1, a 2, and we would hopefully recognize that as a root 3 and a negative root 3. So this again is a 30-degree angle. Around to here we're 30 degrees short, so theta could be 30 degrees or 30 degrees short of 180, 150 degrees. Or in radians, 1/6, 2, 3, 4, 5 sixths, pi on 6, or 5/6 pi. Okay. When is tangent 1 or 1 on 1? When is tangent positive? Here or here. Y to x, 1 to 1. Well, that is clearly a 45-degree angle and a 45-degree angle here. One full revolution. Theta is 45 degrees. Or 180 and 45, 225 degrees. Fourth pi is 1, 2, 3, 4, 5, either 1/4 pi on 4, or 1, 2, 3, 4, 5, 5/4 pi. And secant, notice the first thing I'm just consistently doing is just making these fractions. Secant is r on x. Secant is positive when cosine is positive. All students take calculus here. A 1 to root 2, that's a dead giveaway, 45. So we'd have a 1, a 1, a root 2, or a 1. Put that up here. 1, a negative 1, and a root 2. But either way, we're dealing with 45-degree angles. So theta, again, I can't call this negative 45. I've got to run around to it, is either 45 degrees or 45 short of 360, 315 degrees. This is fourths. 1, 2, 3, 4, 5, 6, 7/4 pi, or just 1/4 pi? Pi on 4, or 7/4 pi. So whole lesson. By the time we're done with this homework assignment, we should become very, very comfortable with our 2 a.m. wake-up calls: secant r on x, tangent y on x, cosecant r on y, cotangent x on y, etc. We should become very comfortable with those and just naturally need to absorb those. Got to get yourself away from strictly thinking in terms of SOHCAHTOAs. Okay, here's your assignment from there. I think we're going to have a lot of confidence when we're done with this assignment and be moving forward into graphing some trig functions very quickly. Good luck.